Hello everyone, this is Mr. Underkoffler, and today we're looking at the guided notes called Similar Shapes, Finding the Missing Measure. Similar shapes are different sizes, but congruent angles. So what that basically means is that you're going to have one big version and one small version. Small version could be first, it doesn't really matter, but they're the same type of shape. And so exact same size of angles, it's just that one's a bigger version than the other. So that's what we're talking about here. Now, here's the key. Go ahead and underline this on your page. You can set up a proportion to solve for the unknown measure of a side. Now, proportions are something we did earlier this year. A proportion is a fraction set equal to a fraction. The beauty is you can decide how you want to set up your first fraction. You really can. So, for example, number one, you can see the first shape has 23 meters and x meters. If you want to make your first fraction 23 over x, you may, no problem. But then your second fraction, since you're going to set it equal to the first, must be set up the same way. So notice how the 23 is this top short side. Then we need to, since we put that in the numerator, we're going to have to set up our second fraction using that same type of side from the other shape. So that would have been the 18 meters. And then since our denominator was the right side here, this side called x, we're going to have to make the denominator of the second fraction that same type of side, which was the 62 meters. And so there you go. There is one way of setting up a proportion for problem number one. But is that the only way? No. If you want to make your first fraction the x over 23, then simply make your second fraction 62 over 18, because the x and the 62 are the same type of side. The 23 and the 18 are the same type of size, so they have to be put at the same place in those fractions. How about problem number two? I bet a lot of you could set this up on your own right now. If you want to make your first fraction 12 over 16, what would your second fraction have to be? Stop and think. Where did that 12 came from? From this left side. Well, who's that side on the bigger shape? It's called x. So since 12's in the numerator, x has to be in the numerator. What about the 16? It's this longer side here on the bottom. Well, then 25 has to be at the same place as the 16, so it goes in the denominator. But what if you wanted to make the first fraction 16 over 12? Then what would your second fraction have to be? You can go ahead and write it down on your own. I bet you probably know what it's going to be. It would be 25 over x. Now, do you have to write two proportions per problem? No, you do not. You only have to write one down per problem. I'm just showing you what the options could possibly be for those first two problems. All right, now, we're not just going to write a proportion and leave it the way it is. We're going to use it to solve for finding a value of x. So problem number three, we're not just writing one, we're also going to solve it to find the measure of x. All right, so what can we do? Well, you can go ahead and hit pause and write a proportion for yourself. Did you already do that? If not, hit pause real quick. All right, if you made your first fraction 60 over 55, which is the left side over the bottom side, then your second fraction must be set up the same way, the 48 over the x, just like it was 60 over 45. But if you decided to do the 55 on top and the 60 on bottom, then you would have to do the x on top, because x and 55 are the same type of sides, and 48 and 60 are the same type of sides, so that would be your second fraction, x over 48. I do not care which way you choose, pick whichever way you want. And if your left fraction is on the right and your right fraction is on the left, that's fine as well. All right, how do we solve a proportion? It's been a little while since we've solved proportions. What you're going to do is you're going to cross multiply. So you're going to take x times 60 and you're going to take 55 times 48. Go ahead and use your calculator. Go ahead and get it out if you don't have your calculator out yet. We know x times 60 is 60x. 55 times 48 is 2,640. Keep an equal sign in between. Now, how do we solve for x? Inverse of multiplying is dividing. Go ahead and use your calculator to figure out what 2,640 is divided by 60. Use the calculator for that. Did you already do that? Well, 60 divided by 60 gives us x by itself equals, what's 2,640 divided by 60? It should give you, in your calculator, 44. Now, what's the unit of measure? Look back at the drawing. Everything here is in feet, so that means it's going to be 44 feet. And there you go. That's pretty much all there is to it, to solving similar shapes problems by using proportions. I would like for you on your own to try 1, 2, 3, 4, and 5, and then you'll eventually use a solution sheet either today or maybe tomorrow in class to check your solution. So that's it for this video. Thank you for watching. Go ahead and do 1, 2, 3, 4, and 5 on your own on the back side of the page. Thanks for watching.